to optimize your code. You need to do this sort of stuff. Oh, no, it's too expensive. We're just going to double the number of cores. So they go from 4 to 8 cores. Within a week again, it's like, oh, we're running at 100% CPU utilization. So again, we're going to double cores. No, you need to do this. No, we're just going to double the size of the M. So now we're running 16 cores. You know, I've got customers, I keep saying at the user group, where they didn't want to pay for a $40,000 performance tuning engagement, ended up burning $1 million in a short. And then in February of this year, oh, can you come in and tune that system? Because we just burnt $1 million in Azure. And then again, this was too difficult. So they, again, just whatever. Anyway. My MD probably. I don't know. Anyway. So the idea here is people are going from on-prem into the cloud or virtualizing or consolidating, and they're getting performance bottlenecks again. And one of the potential problems is because of temporary objects and scalability and some of these things that will be discussed. And this could potentially be very, very difficult to solve or tune in the cloud, so just be aware of that. So that's why we're talking about these sorts of things. Okay, so what considerations apply when you're choosing your particular type of entity? So you've got table variables, or we've got temporary tables. What are the considerations at a high level of whether you should be using one structure or another structure?
How many rows?
How many rows? So the volumes of data. Is it going to generate 10 rows, or is it going to be generating 100 million rows or 10 billion rows, or whatever the case is? What else? So, do we need to index the structures? Absolutely. What else? Statistics? Yes.
What are you going to do with it if you're going to just create it and read for it once? Or?
Yeah, absolutely. So that you're going to create this temporary structure once and destroy it? Or you're going to reuse it a number of times downstream in your code? Yes. What else?
How long do I have to keep it for?
How long you have to keep it for? Yes.
Share it between sessions.
Do you want to share it between sessions? Yes. Although we don't cover anything in that space. Anything else?
Do I need to partition it?
Sure. You're going down my particular path. What else? Which is all correct. There's just another little path that you also should be looking at. So pretend it's in a stored procedure.
Data distribution.
Data distribution, yes. Scope, yes. Yes.
Recompilation.
Recompilation, another path, but yes, absolutely. What else do we have? Just one more. But actually, the other consideration that you'll find out is also what version of SQL Server you're using. So we're using SQL Server 2012 versus 2014-16 is also going to make an impact on this as well. The thing that I was asking was how many people are going to use it concurrently. So you might have a stored procedure that uses 10 tables and it will be used once or multiple times, etc. But how many people are concurrently going to use that particular stored procedure as well? So the concurrency of use of these objects through the different instantiations of that stored procedure's execution. There's probably a few more. But at a high level, I just want us to start thinking about these sorts of things. And also, again, choosing the type is how is it going to impact performance? So is one object better than another object because of its impact on performance? Which sort of ties into what people were talking about. But again, we'll have a look at the mechanics of how these temporary entities work and how they're going to potentially impact performance. So again, I'm just trying to build up an overall picture of, you know, we have different paths to take of what objects we're going to use and what are the considerations, how it's going to impact performance. And most people don't think about the impact on performance. 20 years ago, people used table variables because people thought that table variables are in memory structures. And as you hopefully know by now, table variables are not in memory structures, they reside inside TempDB. So again, the industry found out, oh, you know, we thought they were table variables and we've been using them, and they're not table variables, so they impact TempDB, etc., etc. So again, another important consideration is how will that impact performance? And there's different ways in which it can impact performance, be it due to the size of the data, and that might be the number of rows, but it also might be the number of columns as well. It might also be the usage pattern. So again, do you use it once or do you use it multiple times? And then again, is it being called multiple times in a concurrent environment, or is it not? So again, that's going to definitely impact performance. So let's have a look at some scenarios and ask some questions. So this is a very common scenario that I see that is for a, let's say, non-SQL developer. That's how I tagged it. So this is a common pattern. So as you can see, it's create proc, whatever, as select star into temp table 1, and then you do some processing. So this is sort of like pseudocode, but you do something to it. So select star from table 1, select into temp table 2, then you select from it, select into temp table 3 from table 3. So,
Yeah, we get it.
yeah, sorry, I shouldn't have that. Okay. No, nobody said that in Melbourne. Okay, so you're doing a select into from table 1, from table 2, from table 3. Sorry, I shouldn't have that. And then finally do a select into table 4, select from table 1, table 2, table 3, and join them together. So a common pattern that I see out there. So the question, again, throw to you. What is potentially wrong? What's going to impact performance? What can be done better in this particular piece of code?
No indexing.
No indexing.
No on clause. Like fully Cartesian join at the bottom.
Well, that's got dot, dot, dot. So again, focusing on the wrong things, but that's okay. Sorry?
We've got a semicolon.
Semicolon, you closed it off.
It's pseudocode, it doesn't have to be correct.
That's what you said in the
Okay,
book.
So you're reading twice.
in other words, I'm not wrong about anything. Thanks for recording this. So what's wrong with a pattern? What's wrong with a pattern I'm thinking here?
Select star.
Okay, so select star, yes, absolutely. So what's wrong with that? So well, what's the question? Select star, do you need everything from that particular table? Okay? So again, I'm looking at, for example, working in Asia, where you have a table which is 400 gigabytes in size. It's 1 billion records. And it's a table for a financial institution where you've got all these last modified by, last created by, all these fields. You're doing some calculation for end of month processing for a bank to ascertain risk and whether a bank is soluble, etc. So the idea here is, do you need all of that particular data? So just quite simple, you're doing a select star instead of saying select just the tables that I want to choose. Okay, so yeah, absolutely. Okay, so you do need that because again, it might not make a difference when you've got a small temporary table, but again, if you've got a 400 gig table that you need to scan to get everything from, it's going to be a problem. And that's a subtle point, but what's the main problem with this?
Selecting twice for no one tables.
Sorry? Yeah, so the problem here is, that's why I said it's a non-SQL developer. I tend to see a lot of this where people grab a data set, put it into a temp table, grab a data set, put it into table variable, grab a data set, put it into temp table, and then join it together. So it's very much sequential. So SQL Server can't do this until it's done this. It can't do this until it's done this, until it's done this. So the idea here is I see a lot of patterns where, again, I had a customer where we had to, insurance company, they have to buy products in 14 seconds. Sorry, in 8 seconds. And now it's 14 seconds to 24 seconds. So the SLA, they own 90% of the market, is to buy insurance within 4 to 5 seconds. And the code's taking 24 seconds. So we're trying to optimize it, but it's 1,500 lines of the worst code that you could possibly see. And the first 3/4 of the code are this. And this is taking 2 seconds to run. So it's 2 seconds of sequential execution before you get to the critical code, which is taking 20 seconds or whatever it was. So the simple one here, just keep it simple at this stage, is that this particular pattern can potentially be done in parallel, which is using derived tables, CTEs, or whatever the case is there. Okay? So just again, something to think about. But as I said, I've seen a lot of non-SQL developers think sequentially, generate this data, generate this data, generate this data, join it together, as opposed to being able to join together, let SQL Server parallelize it, and so forth. Sometimes you do need to do this. So you will also find that sometimes you have too many joins, you over-parallelize, and it's better to create one big data set into the temp table, and then join that to the rest of the joins. So that's why I really don't want to say you should use this pattern or this pattern. What I want you to get away from this session is thinking about the things to look out for and try this versus this and see which one's better, because it depends on cardinality and data and all sorts of factors like this. But in this case, I just wanted to draw out 2 main things. I think it was just the fact that it's sequential, so it'll never work quickly because it has to execute in a particular order, and the fact that you've got select star, which might be potentially too wide. This is looking at a high OLTP use case. So in this particular case, this is something for like a betting engine. So we've got, 10,000 bets placed per second, Melbourne Cup, whatever, AFL Grand Final type scenario here. So in this particular case, as you can see, we've got a little pattern here. There might be a few nuggets here. So again, create a procedure, declare a table variable, column 1, 3 to 50. There's data types here. Select into that particular table variable, select star from a data set, and then select from that, and then do some updates, whatever. So in this particular case, as you can see, it's not wide tables. In this particular case, you have a large, high volume of concurrent queries. So that's the problem in this particular case. So you need to process a large volume of small transactions in this particular case. So again, what are the considerations? What could we pick out of this code, nitpick? How could we optimize things here? So yeah, the data types. Do we need these particular... I don't even know what the answer is, I've forgotten. So the idea here is, sure, is this is a big int, does it need to be a big int? Can we make this structure actually smaller as well? Again, end varchar, can we get away with a varchar? I assume that's why I've put in the variables or the data type. So that's, yeah, sure, absolutely. What else?
Can we declare an integer, a key of some description of a constraint?
Yeah, so constraints, keys, indexes, let's say.
Yeah.
Maybe we should also, is it correct that we're doing a table variable versus a temp table in this particular case as well? So again, I'm just saying, I don't know what the answer is, but these are the things to think about there. Again, select star. Again, that might be wrong, but okay, fair enough. Anything else? One last thing.
That's the stats on this little refresh log.
Yeah, sure, absolutely. So absolutely, stats, indexes. One other thing that you haven't mentioned.
There is no way of handling.
The table variable? I'm assuming that comes later.
Oh, we should have, yeah.
That's it.
If
So
it says it into
Yeah, dot, dot, dot. So yeah, what else?
There is no error handling in store procedure. Try catch or
There is
no error handling.
Yeah, sure, it's down the bottom. Dot, dot, dot.
There is no. There should be try log. Begin try.
It is there. Dot, dot, dot. You're going down the wrong path. One other thing. This is orthogonal to what we're discussing.
Is it understanding the column names? Like they just look so generic.
Pretend that code doesn't exist, in other words. There's your hint. What is the performance of this whole system going to depend on now? Now it's not so much SQL Server code. What is it?
that's
It's not like size set.
Huh? Sorry?
the compilation of it. Is that what you-
Yeah, no. No. Sorry? TempDB performance, yes. Okay, so in this particular case, it's not so much the code, although there are issues here. I'm not saying there isn't. Now it very much depends on your TempDB configuration and your SQL Server environment and the number of cores, etc. Okay, so sure, there are some issues here with the code, but now it also depends on your SQL Server environment. In my particular case, again, I was working for one particular company. They had SQL Server 2012 running on Windows 2008 on a machine with 100 gigs of memory running off a SAN, spinning disk. They could do, let's say, 100,000 bits per second, transactions per second. They spent $500,000 on hardware, 4 availability group replicas, 4 Fusion IO cards per replica, and 768 gigs of memory per server. They tested the old system, 100,000 transactions per second. New system, 25,000 transactions per second. All CPUs are running at 100% CPU. So they cannot get to the 100,000. And we've just spent 8 months, 2 years on a project and $500,000.
What version was the new server?
SQL Server 2014 on Windows 2012
Was
R2.
the cardinality estimator?
No, it wasn't that in this case. So in this case, the problem was, on the old system it had 48 cores. On the new system it had 32 or 24 cores. So it was a difference in the cores. They didn't need the SSDs and the RAM, etc. SQL Server wasn't even using 762 gigs of memory. It was only using 500. But it's funny that it was, again, on a machine with 100 gigs of memory versus 762 gigs of memory. Bad code, but the cores were effectively handling it on this old system. But because enterprise edition is so expensive, they upgraded and were told, oh, there's no need for you to worry about, you don't need 48 cores, 32 will do, you'll save on licensing costs, and it was a problem there. So we spent 3 months furiously fixing the code so it would handle the workload by the time it was actually required. So again, in this particular case, the hardware, SQL Server configuration, and the TempDB environment in particular.
So that sounds like the TempDB wasn't the bottleneck, it was the creation of the compilation of the code.
Yeah, but it was also parallelization.
Because otherwise, if they put the Fusion IO cards closer to the machines, they should have given them TempDB locally.
Yeah, but you're still creating enough concurrent objects, which is a problem. So that's not an I/O issue. If the code takes 3 seconds to run and you're locking the concurrent objects in TempDB, therein lies your problem.
Before
Okay.
we moved the bottleneck with increasing the hardware.
It was too difficult and too expensive, and we can't do it because it'll take 3 months for Intel to get the processes in from the Cisco UCS environment. And management got really narky about, well, we've just spent this money. Why? You know, why do we need to upgrade processes? Why didn't we do this 6, 10, 12 months out? Politics. This is the third scenario. So this is a large batch processing environment. So in this particular case, you need to process a large volume of data. So this is, again, I was working with a couple of banks up in Asia. So again, end of month processing. There's one process. So it's not a concurrency issue in this case. So it's one process that runs at the end of the month and processes all the data for the banks, the risk. So credit cards, interbank loans, personal loans, and then calculates whether the bank's solvent and blah blah blah. So part of compliance in Asia for banks there. So again, you have a look at this particular pattern over here. So you populate a temporary table. Select star into a temp table from very large, wide table, hint, where 1 is equal to 2. Insert into that hash table, select star from very large, wide table, and then you do blah, 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 and that's update, select, blah, blah, and repeat that process. So what's wrong, or where's the opportunities to optimize performance in this particular case?
Too many columns.
Again, too many columns. So you've got select star, so that was picked up earlier. So absolutely, do you need all of this? And in this particular case, yes, because I said there were like 400 columns. NVAR car 20, NR car 50, whatever the case is. Last modified by. Do you need that for the actual calculation of risk? No, you don't. So you can shrink that. Because again, what have we got in this case? A large number of records and a large number of columns there. So absolutely. So if we can shrink the size of the temp table, function of hardware, we should get better performance. Anything else?
Create an index and define the temp table first.
Sure. So absolutely. I haven't got that in there, but absolutely. So back to the statistics, whether you should create indexes, maybe again, whether we should use a table variable or temporary table. What else?
Fewer updates.
Yeah, less up. You got.
Well, let's pretend you need to have them. Okay, let's not focus on the updates. So forget about this.
You
Let's say
do the one anyway.
So focus on the first two statements.
Do we need the way 1 equals 2?
Yeah.
Yes, that's it. Do people understand that particular pattern?
You're creating an empty table.
Yeah. So basically you're saying select star into hash table from very table, and again where 1 is equal to 2. So how many rows qualify? 0. So you create the temp table with 0 records, and then you do an insert into that temp hash table there. Okay?
So it's logging in.
So is that good or bad?
So is that going to cause logging?
Logging or locking?
Logging.
This one won't. This one will take half a second.
Yeah, but the second one.
The second one will.
But if you did it just in the first one, would you then just be logging the pages instead of all the rows?
So, well, not quite, but interesting with where you're heading, but that's not what I'm after at this stage. So we'll answer this question over here. Okay? Somebody could say, for example, going to your line is, what about if I create a permanent table? So instead of saying hash table, say, select into temp table without the hash. Where will that table get created? In TempDB? No, it'll get created in the user database.
Yeah.
So let's discuss that because I don't think that's in the slide. Is that good or bad? Should I create a temp table in TempDB or in the user database?
Sometimes it's.
Yes.
But then you run the risk of multiple concurrent people smashing each other.
Yeah, but in this case you don't care because it's a single process. Large batch process, one thread, one process runs.
Never runs twice.
Yeah, so end of month processing, so you don't have the concurrency arguments. That's why I deliberately put that in. So,
Depends
yes,
on
but
whether,
you're wrong.
depends on whether you've got more.
What's going to be quicker, user table or temp table?
It depends
Or
on whether,
TempDB table?
it depends on TempDB versus log files.
What?
Well, LDF.
So yeah, well, it depends. It depends on nothing.
Well, if
TempDB will
TempDB
be quicker. Why?
Because we don't do transaction log backups with MTV.
Sort of not right, but the right path. You do less logging in the transaction log for TempDB. Because in TempDB, you never need to roll back. So you do minimal logging in the LDF file. So when you do create a table in your user database and do a select into and blah, you potentially have a rollback. So SQL Server will do the logging of the insert and also the undo information to roll back the transaction. Okay? Whereas in TempDB, they've optimized the LDF file, because what happens with TempDB when you restart SQL Server? It creates a brand new empty one. So the log file is written to more efficiently for TempDB than it is for the user database. So that's why, again, if you have the opportunity to create inside TempDB, that's better than the user database because there'll be less I/O through the transaction log effectively. Okay, so just a small point, but again, there's always exceptions, but as I said, just at a high level. Okay.
But you can take that even further and use table variables and alternative logging at all.
You still log, I think.
Not rollback.
Yeah, you're going to do the rollback, but you still have the table variable. Yeah, sorry, yeah, in that sense. So let's have a look at Microsoft's guidance. So again, this is high level. I'm sort of assuming you know on this. So again, just quite quickly, with temporary tables, the benefit is, again, they live in TempDB, so they reside in TempDB. So I'm talking about tables that have hash table or double hash table. And don't forget that you can explicitly create tables inside TempDB. So I can say create table in tempdb.dbo.victor without the hash and then populate with temp tables, and maybe your choice in whether you're using a table variable or a temp table is the recompilation rate. So again, if you have this pattern where populate a temp table, modify some data, triggers recompilation, modify some data, recompilation, 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 that's something that you need to potentially watch out for. So you can see in this particular case, we're just giving you the thresholds for the recompilation there. So whether it's a permanent table, a temporary table, or a table variable. Notice with table variables, we don't have any recompilations because we have no statistics maintained on the table variables, as we'll find out in the next PowerPoint slide there. So as you can see, it's all because of cardinality estimation, so statistics, and if you modify enough records, and it's quite a small threshold for temporary tables, you trigger recompilation, so that's something that you need to watch out for. Table variables were introduced in SQL Server 2000. They don't support indexes, they don't support statistics. So the idea here is you don't have that recompilation problem, and you can see the big problem with table variables at this point in time with a product is that the query optimizer assumes that it returns one record for the result set. So if you're returning 100 million records or 10 million records, then obviously the execution plans can be suboptimal because you're not really returning one record. The big deal, I think, about 5-10 years in the industry is people realise, maybe a bit later now, is that it uses tempdb. Because people said, table variables, use table variables because they're variables and they live in memory. No, they still reside in tempdb. So you still have the overhead to tempdb. So you're not going to win in that sense of creating a table variable versus a temp table in the belief that you think that a table variable is only going to live in memory. Does that make sense?
I guess you create an in-memory table.
Which is interesting because nobody said that's a temporary object that exists inside SQL Server when I asked the question. So, the question remains, when should I use a table variable versus a temp table? What's the Microsoft guidance say? Which is sort of correct but basic. If you're working, well, I think I've got it here. So if you have a small set of data, 10 records, 100 records, 1,000 records, then it's probably worth your while just to create a table variable. You don't have the overhead of statistics, you can reuse it multiple times, update it multiple times. It's not going to really affect too much things. So the idea here, as you can see, depends on the size and also the use. So if you're going to use it once and you're going to do a scan, well, then you don't really need to create a temp table with statistics in any case. Because if you're doing something like select star from it to process it in any case, because you need to process all the records in that temp table, then sure. So again, this is the sort of guidance you'll see. It depends on the size and the usage of that. So small data set, you'd be leaning more towards a table variable. This is not black and white, it's shades of grey. Okay? If you've got a simple use, so simple use is just a select star, again, use a table variable, even though it might be a large or medium data set over here. If it's a complex use, so you've got joins and where clauses and things like that, using it multiple times, then you're probably leaning more towards temporary tables. So that's the Microsoft guidance, so as I said, just a starting point. The next couple of slides are going to talk a little bit about tempdb contention. So don't forget, all of these particular structures live inside tempdb. So the idea here is that, again, depending on your hardware, depending on SQL Server, depending on how tempdb has been configured, you can potentially overload tempdb. So that could be very much the source of your problem. So what I've done over the next couple of slides is just copied some material from various places on the internet. So I tried to find old knowledge base articles, and in some cases they've just disappeared. So I did the best that I can. But as you can see, they're sort of saying, this is from 2000, I think. So you can see over here, when tempdb is heavily utilised, you may experience potential on internal pages. So in particular, we're talking about the page free space and the secondary or shared global application map pages there. So the idea here is, as you're creating all of these particular structures, you're modifying these special pages which track the usage and the space used inside tempdb's extensive pages. So you're creating a hotspot in this particular case. And again, they're sort of reiterating that these particular operations will use tempdb, so I'm not going to go through there. So you can see over here a whole bunch of stuff there. One thing that probably isn't there is triggers, so I think triggers should be there as well. Yes?
RCSI.
Sorry?
RCSI.
Rogue committed, so rogue versioning. This is from 2000, so that's why that's not in there. That's why.
Since
Yeah.
then they've sort of changed the
Yeah,
recommendation to say have more files, which a lot of people never
Yes.
have.
Dave, who's presenting? Thank you, sir. Okay. So we're going to cover all this. So that was from 2000, 2005 days. This is, I think, from SQL Server 2012. So again, I was just looking up old articles. And this is my point. depending on whether you're on SQL 2016 or 2014 or 2012 or 2008 or God forbid 2005, 2000, you will see different behaviour. And you'll see that Microsoft have slowly tuned TempDB. So again, they made optimizations in 2000, then 2005, then 2012, and so forth and so forth and so forth. So this is again just me getting one article that I found that it sort of impacts performance. So in this case, as you can see, assume you use SQL Server 2012, when you do a select into a temporary table, you experience poor performance with I/O, as you can see, TempDB, because as you can see, there's a problem with the temporary table using an eager write operation in the execution plan. So again, just highlighting the fact that as you go through a higher version of SQL, they've identified problems that exist in the field with larger data sets, concurrency problems, and tried to solve them. So they're continually trying to tune TempDB because it is a big bottleneck. I'd like them to create a TempDB per user database. They don't want to do that. I've been harassing them for years. They're not going to do that. But there are some benefits of collation and then scalability, but they're not going to go there. Okay, so it is what it is. But in any case, as I said, again, it's very much version dependent. And as you can see, we're starting to get into SQL Server 2016, so 13.x. So again, they've optimized performance in a major way here. And in this particular case, you'll see that you've got temporary tables and table variables being cached. So if you create that stored procedure that does the select into a hash table or a table variable, and you've got multiple people calling up that stored procedure, in earlier versions of SQL Server, when you call up the proc, it would create the temp table or table variable in TempDB. The stored procedure finishes executing, it destroys that structure. Okay, so you're hitting all those SGAM, GAM pages, allocation, blah, 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 blah. What they did in SQL Server 2016 is cache these temporary tables, table variables. So if you go to SSMS and go to TempDB, tables folder, etc., you'll see all these hash tables with suffixes on them for local or global temporary tables. So the idea here is they've optimized it. So people are calling up a stored procedure, and you're creating the same temporary table or structure. You don't destroy the objects, you sort of create the structure, and you keep reusing it before it gets destroyed. So you've got a massive improvement in performance. So again, the theory is that if you upgrade from SQL Server 2012 or 2014 to 2016, you should see an improvement if you've got this bottleneck. Because again, they saw this in the market and they addressed this issue by allowing the database engine to cache temporary tables and table variables. And as I said, you'll see them inside even Management Studio because they're there, even though stored procedures finished executing, you can still see them and do a select against them, etc. So as you can see, caching allows operations that drop and create temporary tables to execute very quickly because you don't have to destroy all the time. You can reuse the cached object over here. At every stage, they try to improve the logging inside the TempDB LDF file as well, so the transaction log. So again, you can see over here, they're trying to reduce the amount of logging that occurs inside TempDB. And the other thing, as you can see, they've improved some latching and stuff like that. I'm not going to go through this in depth because it's things that you can't control beyond upgrading to that version of SQL Server. But that's the main one. That's added. Now, SQL Server 2008. Yep. Okay. So I was presenting this talk in SQL Saturday last week in Melbourne, and I had a few people come up, or one person came up, and again somebody today came up to me and said, "Oh, did you see Microsoft just released an article?" Pam Lahode, I don't know how to pronounce her name. A really clever person that works for the SQL team. She's just blogged about how they have just improved performance in SQL Server 2018 TempDB. And 2018, I mean this year, sorry, not SQL Server 2018. So the idea here is you can go to this particular blog to find out a bit more information. But what they're doing is putting in patches in CUs that are going to improve TempDB further. So you've got object allocation contention improvements, metadata contention improvements, and auditing overhead, even if you don't use auditing, which is quite interesting because I didn't even know about this particular problem. So this particular problem is specific to SQL Server 2016. Okay? How many people know what Traceplate 2371 does? I don't even know if that's correct. Never mind. So what I've done over the next couple of slides, I don't want to spend too much time on this, is basically just distilled what Pam has said in her particular article. We've got a diagram, so I just completely copy-pasted, lifted and shifted this from the article that she's had. So you can see over here with object allocation contention, by having multiple files that are equally sized, each allocation object hits a different file and thus a different PFS in a round-robin fashion. So they've just changed the way we are round robining within the multiple files, the PFS pages within those multiple files there, because again, they saw a contention with the algorithm of how this object allocation was working, and they've just tweaked it over here. So you can see over here, they've just got a diagram of how they've got a new round robin algorithm to hit the PFS pages for the corresponding multiple MDB file, 10 dB files in this instance there, the NDF files in conjunction with the MDF file there. So they've just, as I said, improved how they've allocated or used the PFS pages to reduce a hotspotting environment. Okay, so you just tweaked it.
Prior to that, they were hitting the first.
Yeah, they were sort of doing this and not, they were doing this way, they were just going horizontally, not horizontally and vertically. So you can see sort of they go to 4, they go to 5, as opposed to 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, like that. So yeah, yeah. So they've gone vertically and horizontally and vertically. Yeah. Yeah. The other thing they did was they saw that if you've got this pattern of creating, so this is just metadata contention. So again, you're creating, destroying temporary tables of the object names and things like that. So you've got another hotspot in the sysObject values table over here. So again, they've just improved some things. So I said, I don't want to spend too much time on this. So you can see over here, they changed the process from being synchronous to asynchronous in this particular case. They reduced the number of helper threads to 1 per NUMA node, but increased the number of tables that get removed in each pass. So again, just some optimizations with how it's worked in the background there. Okay, so again, this is part of the cumulative updates and service packs, etc. So it's a patch for current versions of SQL Server, depending on the version of SQL that you're in. And so here's again just a diagram of how they've done this. As I said, I just quickly pulled that out, so I'm not going to spend too much time on this. So just showing you the algorithms and how it's changed. It's on the website, so just be aware of this and read up on it if you're interested. As I said, I'm not going to spend too much time here because we've got more stuff to cover and we've only got 60 minutes there. The last thing, as I said, so that's again so this is the optimized latching strategy. So again, you can see in this particular case, this is the old strategy, this is the new strategy over here. So again, there was potential for blocking with the old way in which they were doing this. So they've just improved the way they're latching in the background. So again, just saw problems out in the field and again, address this particular problem there. Okay. This one's quite interesting because I didn't even know this existed. So in this particular case, SQL Server 2016 has some interesting behavior in that you can see over here, if you enable common criteria compliance, and this is wrong, also known as C2 auditing, that's two different things. So if you enable common criteria compliance, you basically are hitting 10 dB. But the interesting thing for SQL Server 2016 is you can see this overhead isn't heard whether you have CCC enabled or not. So they've introduced this trace flag in SQL Server 2016, 3427, which bypasses this overhead. Okay, so again, if you've got a high performance workload on SQL Server 2016, and maybe this should be part of your standard operating environment, you should basically have 3427 enabled. And I wasn't even aware of this. Notice that you don't have to do this in SQL Server 2017. So this is specific to SQL Server 2016 as well. So in earlier versions of SQL, you should configure trace flags 1117 and 1118. In SQL Server 2016, you don't need to do that because that's default behavior, but you should be enabling 3427, whereas in SQL Server 2017, you shouldn't bother about any of this. So if you want to do an upgrade to SQL Server 2016 or 2017, you should be? No? What should you be doing?
2017.
No, should be calling Victor Isakov to come in and help you upgrade and optimize things. Okay? Okay, so just be aware of that because I said I wasn't even aware of this. So let's start to talk a little bit about optimization techniques for all the stuff that we've discussed and hopefully talk about some new stuff. So this is just looking at the 10 dB configuration. So again, we've got this world of device out there, we've been talking about it forever, but people still don't configure 10 dB correctly. Okay, so at a high level, I don't want to spend too much time, this is generally what you should be doing. Critical to optimal performance to get 10 dB right, because we use it for a whole bunch of stuff, both temporary tables and table variables, as we said. At a high level, keep it simple, multiple data files, number of data files equal to the number of cores, same order growth, good order growth, good initial size, same order growth because you didn't listen to me the first time, and instant file initialization. Okay? Now, Microsoft said the number of data files should be equal to the number of cores. And then people got a bit carried away and they said, oh, they've sort of retracted or changed the article to say, oh, you should create up to, I think, 8 10 dB files, and if you go beyond that. I would have no hesitations of saying go to 16 or 32. So if you have a physical server or VM with 32 or 16 cores, just put in 32 or 16. I don't find that excessive, to be honest. And what I meant by good initial size is like I just do, let's say 1 gigabyte each, 32 files on a 32 core system, a good auto growth. Don't do the percentage, do 100 megabytes or something like that. Okay, so I don't like percentages because that can cause problems. But again, the idea is you configure all of the files correctly. Okay? Of course, this depends on whether you're using TempDB, but as I said, these are at a high level is what the recommendations are. And also instant file initialization as well.
Is there anything in the PAS that we can configure? So certainly we don't see what's happening under the covers, but is there anything in the PAS level that we can do to, help if we use a lot of TempDB, or we just got to take Microsoft's word for it?
Better design to less TempDB.
Give Victor a call and come in and yeah.
That's not that it doesn't exist. It's more like
No, that's the whole idea beyond platform side. Don't worry about these things. Anyway, so this is just talking about early versions of SQL Server. So you should be enabling trace flags 1117 and 1118, which control what? We're going from mixed extents to uniform extents. So we're using 64K structures at a time. So one extent is available to one object, and the other one does what? Same auto growth for the, okay? So this is no longer required in SQL Server 2016 onwards because this is a default behavior when you install the database engine. Okay, so pay attention to those sorts of things because they should become part of your SOE. Notice again trace flag 3427 for SQL Server 2016, which is that common criteria logging even though you don't have that enabled, which might impact performance. When you're looking at TempDB configuration, hardware matters. So obviously, if you've got spinning Rust disk, it's going to be the slowest. So Flash is going to be quicker than that. You also got, are you going to use a SAN or using local as well? So I forgot, and I put that in a second time again, just an hour ago because I didn't read this sentence. Don't forget that if you're using a SAN, you could be overloading the SAN, or again, local storage might be quicker, or you could get cheap storage that's fast locally. So your SAN's ultra expensive per gigabyte. You can install an M2 device or a PCIe SSD, install that locally. Remember that you can install and use local flash storage, which now SQL supports in different versions. That's going to be faster. So again, the point that I'm trying to make here is that hardware does matter, configuration does matter, Windows matters, what version of Windows, etc. matters in this particular case there. I keep harassing the SQL Server team to put in the feature in SQL Server that used to exist of being able to pin 10dB in RAM and leaving it there. So that was an old feature of the product where you could say 10dB is pinned into memory, we never use disk. And I'm not going to do that, they refuse that. So then I'll be sneaky, I'll harass the Windows Server team to support a RAM disk. So you can install, install features and roles and RAM disk, install it, etc. And I said, hey, it's easy because if you go to your KB articles on support.microsoft.com, there's actually a knowledge base article with all the source code for ramdisk.sys. But they said no, so I keep harassing every year, so eventually we'll get it. And it could be used in so many places.
Persistent memory is very close to the direct standard.
Yeah, but you've got 128 gig DIMMs now. You can get 64 gig SODIMMs for your laptop. So my laptop's going to support 128 gigs of memory. So you might not need a big 10 dB, you just want a fast 10 dB. So you know it's only going to be 30 gigs in size. So I'm quite happy to sacrifice 1/4 of my 128 gig DIMM in a server to get DDR4 performance.
Persistent memory.
Well, that's only 32 gigs in size at this point in time.
Mate, you harass the memory guys.
Nobody listens to this. But the point is, as I said, this does matter, okay? Yes?
It should, we're talking about, persistent memory and RAM disk and stuff, but, that survey talked about the betting guys using with, 700 gigs of memory life, regardless of the CPU constraints you had there. What would be the impact of taking 100 gig of your buffer pool as 10 dB before spilling over to disk?
That would be really good potentially.
So
it depends on the environment, obviously. But the idea is you can go and buy a RAM disk software. I've got one that I use on my laptops and on my PCs at home. So I put the temp drive and everything there. So I use it all the time for various reasons. And you get a virus, you just reboot the machine, it's gone out of the temp directory. But the point is, if you're putting it in AWS or Azure VMs, you sort of don't want to use $20 software to run your eBay environment type thing. So it's not Microsoft certified, it's not. So that's what I'm saying. If the Windows Server team put it in there, then it's sort of qualified to work with Windows Server. Then people would use that. And other people, you could use it for staging and all sorts of things. You could use it in multiple locations. It just wouldn't be for 10TB SQL. There's multiple use cases.
What is the reason they give it for not doing it?
Can't be bothered. Can't be bothered recompiling that code that's already there.
Yeah, so Maxwell said that.
Why do I need to answer that question? They got rid of the start button, made somebody rich because he was selling a start button in Windows 8 for like $1 million, and they put it back in 8.1. I don't know. Anyway, so let's get back to this particular question that I asked over here. Populating temporary tables. Which one is better, if any? And there might not be any, but there might be. I'm not sure. So again, you can see we've done a select star into hash table from very large wide table. Forget about that. Where 1 is equal to 2. So we discuss this pattern, it creates an empty table, then we insert into that table using insert into that hash table, select star from very large table, versus on the right hand side, we've said select star into hash temp table from very large wide table. Which one's going to be better, if any?
Left one.
What, sorry?
I think left one will
The
be
left one would be better. And why is that?
Because it will not hold lock on very large table while creating temp table, and will not hold. It will be quick lock on
That's one
temp as well.
opinion. Is Russia going to win the World Cup?
Yes.
I know Australia's not.
Well, it all depends which.
But we're really proud of them, because they did good. You've got to get to win.
Yeah, but it's soccer, so who cares? It's not footy.
Okay, so we've got one vote on the left. You can say it's not making a difference.
Well, if I had the opportunity to create the index up front, yeah, I'd go with it.
Okay. Create index on the left, so therefore left. Any other opinions? Andreas, you're a master.
Yeah.
You keep telling everybody every second sentence, I'm a master, I'm a master. Well, come on, master. Pass this multiple choice exam question. Which one's better, left or right?
I would not trust my gut feeling. I would test it. Depends on the amount of rows, and maybe in the end you get a few seconds more on this side, and then you run it again, it will be equal. And then
Okay, so you're sort of sitting on the fence. It's very German of you, very United Nations.
The
Okay.
middle one.
Do we have anybody on the right-hand side?
I would consider the right side.
Okay, so what if I were to tell you one could take 8 hours, one could take 20 minutes? Which one would it be?
One array would be quicker, a table lock on it.
Forget about locking, because you can do the same on both.
This is one of my one.
No, they're both minimally logged. So, do you want the answer?
Sure.
Do you really want the answer? Everybody's screaming, yay! Yay! This one can take 20 minutes, this one can take 8 hours. So the one on the left is worse. SQL Server 2014. Why?
Parallelism.
Yes. Did you go to talk in Melbourne?
No.
You talked to somebody that went to a talk in Melbourne?
No.
You didn't know the answer. Absolutely. The problem in this particular case is this code will run on a single thread. This one will run in parallel. So this one literally at the bank, 8 hours type thing, 4 hours versus 20 minutes in this particular case. And that's one thing that I was surprised by. I thought, oh, that's right, they introduced parallelism in this version of SQL and blah, blah, blah. And that's one thing I don't see anywhere discussed at all when people are talking about temp table variable creations of parallelism. Because they're always talking about, here's a table variable, here's a temp table, blah, 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 these are your considerations, etc. Nobody's talking about that one's executing on a single thread, the other one's executing on multiple threads. We have 10 minutes to go, who cares? We're going to talk till midnight. So this can be a very, very big factor. Now the problem here is, and by the way, this is why I wanted to talk about this at the past summit in 2018 and this session got rejected.
Is that specific to tech tables?
I didn't get that.
So the point is that this should be important. As I said, I never really thought about this. And when you're working, as I said, you're working with a bin and record table with 400 gigs worth of data. You start to think about these sorts of things because again, you've got something that's 15 days to run, and you're trying to get it down into a 5-hour SLA. There's all these things that you never thought about. So in this particular case, as I said, never really thought about it. Or maybe I did and just forgot. But the idea here is, as I said, massive difference because this went in parallel and this in. So that's something to look out
If
for.
it's not a template.
2014.
Okay, because I was going to say,
Why
I
not?
did that the other day.
It's a selected
That's
optimization.
No, exactly. That's where you have to be careful. And as I said, I'm not quite sure. You know, as I said, I was going to do demos and things. It's too hard because it depends on whether you're on 2016 and 2014 and So no, exactly. It's good to know. So that's why I'm not giving you. You should always do this or do this. You should look for parallelism. You should look for this. So these are the considerations. That's a takeaway one from this session.
Is that the same statement true for like a proper table? So if I was to create a physical table,
Correct. Yes, I think so. From memory, yeah. From memory, because I tested all of this. I've just forgotten it all.
so
Too many nights and too many miles. It's because it gets version specific, I said, but it's easy for you to test. It's easy for you to test one or the other and see that it's a parallel versus. Yeah, exactly. But as I said, we don't see a discussion on this at all. Yes, question about.
Did you force max stop on the left one?
Yeah, I was trying to do that. Again, it depends on the version of SQL because you can force parallelism in certain versions of SQL with query hits, but other versions you can't. So again, yes, you could potentially.
I think the latest version.
Exactly. As I said, this was on 2012 or 2014. I think 2014 might have been 2012. So there were options that weren't available to us because it added this enhancement. But the idea here is I said, why are they running this stupid pattern when they can just do this? So I ran this and it's like, this is 20 minutes versus hours. What's the difference? Yeah, obvious. It's parallelism.
Yeah, but if they'd adopted it in 2008, so I've just done that. The other one.
So as I said, but it's something to watch out for. So it might depend on other factors.
That way, and now they're going to come back again.
Okay. What's the other thing that we did in this particular case? So something that nobody's talked about as well, and I don't see anybody talking about, is compression. Okay? So again, think about this. So we talked about reducing the number of columns. So instead of being select star, select column A, B, C, D, E. But the other thing that I found in this particular case is if we enable page compression in this particular instance, we had data that was like 800 gigabytes, whatever it was, 400 gigabytes in size, go down to 20, 40, 100 or whatever the case is. So if you're doing that initial select star into or insert with a nested select statement, and you've got a table that used to be 400 gigabytes in size, and you compress it down to 20, 30 gigabytes in size, then that initial population is going to be quicker because you're doing less work on the SAN, etc., going through the buffer pool in this particular case. So also evaluate compression benefits on the source table, especially if you're data warehouses, so row versus page compression. You might have CPU overhead, but in this particular case, end of month bank processing, who cares? You've only got one process that runs on that particular system. You want to have that one process run as quickly as possible, use as much CPU as at once. So again, we found that in this particular case, when we enabled page compression, we got really good savings. I've done some work with some fast food giants here where we had tables that were literally, again, you've seen me present this, 400 gigs in size, down to 4 gigs, 200 gigs in size, down to 4 gigs. And their reports that took 2.5 hours to run were a series of reports were down to less than 5 minutes.
You consider columns to index?
Correct, absolutely. So that's something that hasn't been mentioned at all, so thank you. Yeah, so again, you never thought about it. So yeah, you could take that step further, use column store.
I don't know if all the overhead would kill you, but...
No, that's something that I talked to Melbourne and said, what have people forgotten? Nobody mentioned column store.
Page level has a certain amount of overhead.
But the benefit of column store is twofold.
Well, it's extracting that.
You've indexed all the columns.
column store, your devs have to be on board.
Yeah.
Like, no use putting in column store if your devs don't know how to run.
Also, yeah, sorry, okay, no, let's park that offline, we'll come back to it. We'll park that offline, okay? So, again, you can see over here, CPU overhead might be unacceptable, but again, in this case, there's end of month processing, etc. So just be aware of the fact that compression can take up. Now, again, let's imagine you get phenomenal savings with compression. So you're down from 800 gigabytes down to 40 gigabytes. How about we solved our problem with that, select into and
No.
Why not?
You shifted the bottleneck.
Well, we sort of solved half the problem because a source table is a 40 gig scan instead of an 800 gig scan. What was the problem when we created the temp table? Pretend we do a select star into a hash table because we need all the columns. Well, does it or doesn't? That's a question, isn't it? So if I do a select into hash table from a compressed table, the hash table, has it inherited the page compression property? Probably not. No? Anybody for yes? Who wants to bet their house?
Yeah, I don't have a house.
Neither do I. No, so again, surprised. No, it doesn't. So the idea here is, again, we sort of won with page compression, but 10 dB is now an 800 gig temp table. So you sort of win, but then you sort of don't win fully. Well, what can we do instead? we can say create hash temp table, blah, 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 with compression equals to page, and then do an insert with a nested select statement. Have we one here?
No,
Why?
because you're going
Back to a single thread in this particular case. Okay? So, as I said, this was sort of what we were doing, what I was doing with this particular project. So, just, this is all interesting. I've never seen anybody blog talk about this sort of thing. So, again, you could consider compressing the table, temporary table, but will it run in parallel when you use it? And then I think it's going to depend on SQL Server edition versions. And again, you've got query options to force parallelism with later versions of SQL Server as well. So don't ask me, I don't know. Depends on the version of SQL, depends on the patch. I've seen different behavior in different versions. That's why a demo for this was really hard. So again, I reached out to Microsoft. I wish that you would, if you did a select into it, would inherit the page compression properties of the source table. And Microsoft, of course, said, yes. Victor, no. No, Victor, no. It's all I hear from Microsoft. Are you...
Maybe they have a standard
no.
email template.
Yeah, no, just like no. Outlook rule. I'm not that important anyway. So again, this was interesting where again I thought, okay, if we create the temp table and try to populate it, again it went back to a single thread. So we didn't get the full benefits there, in that case there. So again, it's, as I said, it depends on the version of SQL, so try different things, look at the execution plans, look at the size of objects, and that will help you then have an optimal solution here. So the other thing, as I said, that we haven't talked about, and that's why I asked the question, what kind of temporary objects do we have inside SQL Server? We talked about table variables and temp tables, but nobody mentioned in-memory LTP tables. So that's something else that David did later on, but not at the time. So, so he was wrong then, but he corrected himself. So the idea here is, don't forget that you've got in-memory LTP table capability, but it's only available in Enterprise Edition until you get to SQL Server 2016 Service Pack 1. So in 2016 Service Pack 1, it's available in all SKUs, be it developer, MSD, or whatever it's called, standard, etc., etc., etc. So with memory optimized table variables, they're stored only in memory, there's no component on disk, which means you're not going to hit 10 TB at all in this particular case there. So it involves no I/O activity whatsoever. So have a look at that. There's some limitations or things like that. So again, Microsoft's claim, results can do a speed increase that are 10 times faster or more.
It's just massive gotcha though, like when you use in memory, you have to know what your data is, how much data you have, and like you can't have change. Like if you have change and you don't define enough, what are those index?
Yeah, but this is okay for this sort of stuff, because what we're doing in this particular case is this. We're saying create a data type table, blah, 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 in memory optimized. So we're not really talking about creating 10 tables, we're just talking about using in-memory LTP variables as opposed to 10 tables or table variables.
So I was talking like in-memory tables.
Yeah, so you're absolutely correct. But I'm just talking, so forget about in-memory LTP tables, we're just talking about using in-memory LTP for this sort of stuff like this.
It's non-persistent tables, not persistent.
Yeah, so they're non-persistent, blah, blah, blah. But the idea here is, as you can see, create type as table, and then put in with memory underscore optimize equal on. Now be careful with this, because you might do a little test in a lab or a POC or your laptop, etc., and you do 10 tables or table variables, and then you try this, and you'll find that this is actually slower. Don't be perturbed by that, because the idea here is when you're doing little tests and simple databases and simple concurrency, you might find that table variables of 10 tables outperform this. It's when you get to scale, large number of concurrent transactions with non-locking architecture and blah, 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 that this is going to shine because you've got no contention on 10 dB. So just be careful of that, but you have the capability of using this particular technology there. So again, just be aware of the capability of this product. Do a search on Jos de Bruin. He's got some articles on how to convert that. I think it's part of the SQL Server documentation now. So again, remember that you can use this in standard edition or above to get rid of table variables and temp tables in highly concurrent workloads we overload at 10 dB. Okay, but again, as I said, we're not talking about in-memory LTP, we're just talking about using them as substitutes for those temporary structures there. The thing that I really hate, and I said to Microsoft, and Microsoft again said no, is that when you want to use these particular structures inside a database, you still have to create this memory optimized data file group, even though you don't have any persistent or durable in-memory LTP structures. So all I want to do is just use this for variables. I don't want to use this for in-memory tables, be they durable or not. But it still creates this it wants you to create this memory optimized file group for the checkpoint files if you know how the engine works. And the problem with that is, well, you can create it, but you can't get rid of it. And you might have problems where you've got a vendor application, they want you to change things and things like that. So I'm saying to them, well, if you've got non-durable structures, why do we need this particular durable memory optimized data file? So it is what it is. They said it's a bit hard for them to get rid of it. Again, said no, aware of that, etc., etc.
Thanks, Victor.
So, to summarise,
You got it.
30 seconds. So the idea is, what I wanted to take away is not tell you to do this or this or this, but think about the different considerations. Okay? So you can sort of summarise it. So OLTP versus batch, should you use it in table variables versus temp tables, in LTP tables, think about data compression source, temp tables, think about parallelism, SQL Server version makes a big difference as well, and always configure tempdb correctly. I'll leave it at that. If you have any questions, otherwise have a good
Evaluation slide, quick.